is the 2017 soybean insect update. My name is Dominic Reisig. I'm an entomologist here at North Carolina State University in the Department of Entomology and Plant Pathology. Today I'll be covering making smart insecticide choices in soybean, as well as updating you on some new research into defoliation thresholds that has recently been done in Mississippi State. Again, the first thing that I said I would cover was making smart insecticide choices in soybeans, and I've listed the three most critical things that I think are necessary to make that proper choice. The number one is a correct identification of the insect pest. This should go without saying, and it seems simplistic, but the most important but often most underlooked step in pest management is proper identification of the insect. As we'll see using an example in the next slide, part of this is because it's not always easy, but part of it is because we're oftentimes too lazy or don't have the correct knowledge at our fingertips to make that decision. But if we don't know who or what we're treating, we can sometimes make very wrong decisions, as we'll soon see. The second thing is to use our economic thresholds. One word about economic thresholds: these are designed for the average field in the state and the average grower, and no field is average, nor is any grower average. We know that environmental conditions change over time, but these thresholds are a guide, and they should be used before making a treatment decision. And the third thing is choosing the correct tool. And by tool, we're using that analogy for insecticides. We often talk about insecticides or herbicides as tools in our toolbox. And usually when we're talking about tools in our toolbox, we mean different modes of action. And so I've chosen a rock, a hammer, and a nail gun here to represent different modes of action for hammering in the nail. When we think about tools in our toolbox, we kind of think about these modes of action as being present there to delay resistance. And these are good things to have, these different types of tools out there. But let's be honest, some of these tools are a little bit better than others. Obviously, you'd rather hammer that nail in there with a hammer, but if you had a nail gun, you could get a lot more nails in quickly. Be a lot easier than using that rock there. And I know one of the top things on every grower's mind is, what's it going to cost me? That nail gun is going to cost a lot more than that hammer there, and you can expect results accordingly. Okay, so we mentioned our first step being proper identification, and the example that we're going to use for identification is the corn earworm. Now, corn earworm is important to identify in soybeans because it can mean a savings in terms of insecticide choice. So in the past, we thought if we could distinguish corn earworm from tobacco budworm, it could mean the difference of using a pyrethroid, which may cost a lot less than a worm-specific insecticide, or if we had tobacco budworm, we may need to use a worm-specific insecticide. Now, there's different ways to tell the corn earworm and tobacco budworm apart, but one of the ways that I like to use is to actually pull apart the mouth parts and look for that extra tooth inside there. That's called a retinaculum, and you see it pointed with the arrow there. If it's got that retinaculum or extra tooth, that's a tobacco budworm. If it doesn't, it's corn earworm. Now again, there's other ways to tell these species apart. You can look at little tiny hairs on top of hairs, but really anybody that goes out in the field and doesn't use one of these really special microscopic characteristics is really just blowing smoke. These two insects are very difficult to tell apart. Again, this is important because proper identification dictates proper insecticide choice. Okay, so we've talked about how important proper identification is. The second step we mentioned is using those thresholds. Now, these thresholds are readily available on our soybean portal, and you can see the URL is soybeans.ces.ncsu.edu. And if you visited these in the past and you visit them now, you'll notice a little bit of a format change, and so I'm going to just walk you through how you'd find those thresholds on that website. So you can scroll down to the tab that says Insect Management, and when you do that, it'll pull out a bunch of other tabs. Click on it where it says Thresholds, including online calculators. That will then take you to a page that talks about thresholds, but within that there's links. You can find the thresholds for all the different insect pests by visiting the pest pages. Or in the case of our corn earworm, tobacco budworm, we can go to our threshold calculator. In that threshold calculator, we can choose what sampling method we're using. the control costs, we can adjust for the price of the soybean, we can also adjust for row widths. And I'd encourage you to go in there and play with this threshold. A lot of times I'll hear growers say, you know, I put so much money into this crop, it's just not worth it for me to treat this insect. And I think that's exactly the wrong attitude to use, because this insect can cause significant economic damage. And if you put money into a crop and then you let your crop get eaten up by something like corn earworm, you're not going to have anything left to show for it at the end of the season. So I'd encourage you to play with this threshold calculator to help you understand thresholds well and help you understand the importance of treating your insect pests, but only at those levels that are going to cause economic damage. I want to be clear here that these thresholds are designed to help you find that break-even point where the cost of control is equivalent to the damage that the insect is doing. This is not going to help you make the highest soybean yields. It is going to help you make the most money off your crop. Okay, now we're going to talk a little bit about selecting the proper tool or insecticide for our insect. Let's assume that we've determined that we don't have tobacco budworm, but that we do have corn earworm. One of the things that we've been seeing is an increase in pyrethroid resistance over time. We've known about this for a long time with tobacco budworm populations, but we've seen it creeping up with corn earworm. I'm going to show you some data on that in a minute. You can take two different strategies for this insect, one of which is going to be a risky strategy. And that risky strategy would be to use a pyrethroid as your tool that first shot out of the gate. Below are listed some examples of common pyrethroids. This is a chemical class. And I want to emphasize here that bifenthrin, although it's a special type of pyrethroid, it is in that pyrethroid class chemistry. Pyrethroids do have some advantages. They're relatively inexpensive compared to other insecticide classes, and they will pick up some true bugs. So true bugs, examples being things like stink bugs and kudzu bugs. So you're going to get a broad spectrum of insects. However, because they're a broad spectrum, they also have some disadvantages. Resistance, which we've already mentioned. They're not effective on many armyworms, so some types of fall armyworms, beet armyworms, loopers, tobacco budworms. They're not going to kill all your different caterpillar pests that you have out there. And in addition, they're very harsh on natural enemies. We're going to see some data on that in a little bit. Now you can also choose what I'm going to call a safe strategy. You can use a caterpillar specific insecticide. So there's different classes of these, but these are some examples of caterpillar specific insecticides. The advantages of these insecticides is they're very effective, they have some residual, and they tend to preserve beneficials. Of course, the disadvantage is they're relatively pricey, and they won't pick up that broad spectrum of insects like the pyrethroids will. Here's the data I promised on pyrethroid resistance. Essentially, one of the ways that we track it is we collect moths out of traps. They're all males. We put them in these vials that are treated on the inside with a pyrethroid, and we see if they survive or not. We've been noticing that survival in these vials is creeping up over time. Now, I want to be clear about a couple things. It's not easy to link results from these vial tests to results in the individual fields. So I can't say put up a trap next to your field and tell you if you have pyrethroid resistance or not. But what I can tell you is that one thing this test is showing us is that over time, the survival does seem to be correlated with problems that we're seeing in the field. So year after year, we seem to be having more control problems with pyrethroids, and year after year, we seem to have better survival in these vial tests. So, you know, nothing super crazy yet, but we are noticing that pyrethroids are becoming more difficult for corn earworm control than they have in the past. One of the other disadvantages I had mentioned with pyrethroid was their impact on beneficial insects, and this was actually proven recently with a very nice series of studies done by a Virginia Tech student, Dr. Rebecca Whalen, and she actually did some of these experiments in North Carolina as well as Virginia. And what Rebecca did was she put out 3 different types of insecticides in very large plots, sometimes whole field, replicated studies. She left some soybeans untreated, and some soybeans she used belt, and other soybeans she used Prevathon, and then in other soybeans she mimicked besiege by tank mixing Karate and Prevethon together. So Besiege is a tank mixed product that contains the active ingredients of both the insecticides in Karate and Prevethon. And one of the things that Rebecca was interested in is the impact on natural enemies. And so we can see that here in the y-axis she has the number of predators on a beat sheet sample over time. She has pre-treatment counts, and of course they're not different between any of the treatments. And then we notice that in the untreated plots and with the caterpillar specific insecticides Belt and Prevethon, the natural enemies or predators increase in the sample over time. Where she sprayed that Karate and Prevethon mimicking the Besiege, we notice that the predator levels drop initially and really don't recover when we look at 21 days after treatment. So this in fact proves that some of our tank mix products, especially those containing those broad spectrum insecticides, where it may seem like a 2-for-1 deal, are not always as good as advertised. While they do have very specific fits, for example, I would recommend a product like Besiege when you want to pick up caterpillars as well as true bugs. When you have caterpillars, for example, stink bugs or kudzu bugs, I would not recommend it in a situation where you only had caterpillars, because by doing so you would eliminate natural enemies. What's the danger in doing that? Well, the danger is this. I got these calls day in, day out in 2010, 2011 when we had very, very heavy caterpillar years. The grower would call me up and say, I don't understand why I have worms. I already sprayed. Now, of course, you're really smart because you know, based on that last slide that I showed you, that probably the reason why you have worms or caterpillars is because you sprayed a broad spectrum insecticide like a pyrethroid, knocked out natural enemies, those insects moved in behind there, and that's why you have caterpillar problems out there. So in 2010 and 2011 there were a lot of pyrethroid sprays kind of mid-season, maybe around flowering. What it did was essentially release the system and allowed those fall armyworms, beet armyworms, and loopers to come in later on in the season and just wreak havoc on the crop. I want to go back to the tool analogy really quick. I put up photos of two different nail guns here. One is a $23 finished nail gun from Harbor Freight, another is a $300 Milwaukee nail gun. Now, obviously the prices are wildly different between these two tools, but which tool are you more likely to pass on to your grandkids? Is it the Milwaukee or the Harbor Freight? I think we need to think about our insecticides in much of the same light. You get what you pay for. So if you want to take the risky strategy and spray a pyrethroid for corn earworm, that's fine, but please be aware of the risks that are involved when you do that. If you want to spend a little bit more money and use the caterpillar specific insecticides, again, you may be spending a little bit more money up front, but you're probably going to be able to rest easy later on in the season with the extended control that these products often provide. Okay, I want to transition a little bit, change gears, and talk about some of the defoliation work that has been done recently at Mississippi State. There was a student there, I've credited him on the bottom, Ben Thrash, and what this student was interested in was a number of different defoliation questions. Now, I'm not going to go through all of them here, but I think a couple of them were pretty interesting and are pretty relevant to our situation here in North Carolina. One of the questions that Ben asked was, do multiple defoliation events compound to reduce yield in soybeans? So if we have defoliation, say at V3, and then we have another defoliation at V6, how do those two different defoliation events add together to possibly change our threshold? Now in North Carolina, we have a defoliation threshold that is prior to bloom, and then the defoliation threshold that's post bloom. And the reason we have these is because we know that soybeans can compensate for early season damage easier than they can for late season damage, so before you have the reproductive tissues present. Our defoliation threshold pre-bloom is 30% defoliated throughout the canopy. Our defoliation threshold post-bloom is 15% defoliation throughout the canopy. So what Ben has done here is he's defoliated soybeans at V3 and V6. What we have here is a table that's a yield relative to the untreated check. And so we can go through this table and see how these defoliation events relate to each other. So When we have a 33% defoliation at V3 and a 33% defoliation at V6, the yield is about 93% that of the untreated check. So I just want you to follow no defoliation at V3 and defoliation at V6. And what's the point at which we see the yield drop? Well, we have it circled there in the red. It's only when we defoliate 100% of the plant. So it doesn't look like these defoliation events are adding together. It looks like we really have to defoliate most of the canopy before we see the yield loss, and the effects aren't really additive. Another question that Ben asked was, what are the effects of soybean planting date on defoliation at V4? And this is an interesting study because when you think about it, we know that soybeans have different yield potential based on planting date. So when we plant earlier, we tend to capture more sunlight. We tend to escape some of the drought events in late summer, whereas planting late, it's almost the exact opposite. And the situation's not extremely different in the Mid-South and Mississippi, although they are able to plant a little bit earlier than we are here, obviously, since they're at a more southern latitude. The graph that you're looking at here is the yield, and it's pounds per plot. It's not, bushels per acre. But you can see the yield for the non-defoliated plots there in the blue, and the yield for the defoliated plots there in the red. And the percentage there is just the difference between them. It doesn't look like in any of these cases there's much significant difference. There does seem to be a little bit of a trend for a reduction in yield for 100% defoliation, but we know that based on the results of the previous study. When we defoliate 100% of the plants at V3, V6, or in this case even V4, we can expect a little bit of a yield loss, but it doesn't look like it changes across the planting dates. The one effect that Ben did see was delays in maturity, and this is probably something that is the most significant. So even though we may not have a yield penalty, if we run into a year where we have a tropical storm and aren't able to harvest, we can expect a severe yield penalty. So based on these results, Ben has concluded that our reproductive thresholds don't really need to be adjusted based on defoliation that occurred during different growth stages. If we have defoliation during the vegetative stage, reproductive stage, or twice during the vegetative stage, we can probably just assume that it's not additive or multiplicative in terms of thresholds. However, if we do have soybeans that are planted later, we may need to reduce our threshold a little bit so that we don't see those delays in maturity. So how does that relate to us here in North Carolina? 30% defoliation threshold during vegetative stages, 15% defoliation threshold during reproductive stages. I think we can stay safe for beans planted in April, May, or early part of June. When we start planting beans into June or later part of July, we may want to be a little bit more protective of those beans just so that we don't delay the maturity and we can make sure that they're out of the field in time. That concludes the presentation. Thank you.